So hello, good afternoon everyone. We are going to start the assignment of week 11, and it is on noise effect of FM signals. So let us start the first question. Most of the questions of this sample are MCQ type of questions. So the first question is a true false type of question. You have to comment whether it is true or false. So I'm just writing the question. So the question, you have to comment whether it is true or false. So I'm just repeating the question once. It is that the main advantage of the FM system is it performs better against the effect of noise, but it performs worse against the channel nonlinearity. So better against noise but worse against channel nonlinearity. You have to comment whether it is true or false.
The answer is true, I think.
And why should you think that it will perform worse against channel nonlinearity? So as it is frequency FM signal, so that's why you are saying, right?
FM definitely performs better against the effect of noise, but there are nonlinear effects in FM.
Yes.
So
according to my understanding also, I feel that against noise, if I consider only the AWGN noise, not interference, if the noise is only for thermal noise, I say, then as FM we use a huge bandwidth than the AM. So we have advantage against the noise in that case, but it will perform a worse against the channel nonlinearity, because if there is a phase distortion, that will affect the particular frequencies, not the amplitude. Like nonlinearity means is the band, and not every band has same sort of I say this is sort of nonlinearity. So some frequency, I say it, the gain at particular some frequencies it will not be equal, not like this. If I say this band, within this band every frequency component has same sort of gain, but if I say in this picture within this band and this is the channel response, so that is sort of nonlinearity here. So within this particular band we can think like that. So from my perspective it is a true statement. Okay. Now let us go to the question number 2. But the actual answer in the actual sample assignment, it was false. It was mentioned false. So that's why there was a concern. But from my perspective, it is true, because nonlinearity will affect the FM signal more than the M signal, because M signal is only varying the amplitude, where in the FM you are varying the frequency of that particular signal. So nonlinearity will definitely attack more on the FM signal. But there are other concerns also in what I just want to discuss it a little bit more. But there are other concerns also, like in this FM signal. So basically you are spreading this thing over a large frequency. What is not in the case for AM. So suppose you are transmitting at a particular AM band, and this band is getting affected by nonlinearity. So basically what I am saying, the AM signal we are transmitting at a particular frequency AF, so that is the carrier frequency FC. So FC plus FM, FC minus FM, these are the bands we can think of. And at this particular instances, probably there are nonlinearities. Within FC minus delta F nonlinearity and FC plus delta F nonlinearity. So the visualization I can say like this for clarity. Suppose this is a M band, this is a M signal is going through this, and here is a nonlinearity region. This is the nonlinearity region. So let me draw it better. The signal is probably, if this signal is like this, so suppose here is a signal and it goes like this here, and then the band is like this is the filter response, I mean channel response. So in this region there is a nonlinearity. But if I spread this signal over this whole frequency band, instead of sending in the particular frequency, so what will happen, it will spread it over the whole frequency band. If I use a FM type of modulation, so it is using the whole channel. At that particular instance, the nonlinearity in this region and in this region will not affect the signal that much. So in that respect, people can say that FM may have higher susceptibility, that sort of thing, that can be concluded. So it depends on the perspective. But mainly, if there is a nonlinearity, from my perspective, I can say that FM will be affected more than the AM signal. Okay. Now let us go to the second question. This is also a true false type of question. So it says, in a FM signal, both the interference and noise cancellation is odds near the carrier frequency compared to far off from the carrier frequency. It's true or false?
ఏంటా ఇది పడుకోండి పడుకోవచ్చు కాసేపు.
Hello. What?
Is it true?
You. It is odds. It is saying that it is odds near the carrier frequency, right? So why it should be
No,
true?
this is what I thought from your earlier explanation for question 1.
Yeah.
That is what I thought.
Now, what sort of explanation? I did not get it.
So you do some response, no? For AM, you said we have a lower
But this-
sideband and upper sideband.
but this is for
For
FM,
FM,
right?
the interference was shown more at the center, so that's what I thought.
Probably.
Question one explanation. That's what I thought.
Okay. Okay.
Yeah, from this diagram, I thought like that.
But whenever you are sending an FM signal, so you are sending FC plus FM sort of thing, and the message is encoded within this FM. It is a dynamic quantity.
Oh yeah. Now I get it. Yes.
So suppose there is another FM signal is FC2. So suppose our FM signal is like this, and another FM signal is here like this. So the interference will be very low near this region for two different FMs.
Yes, I get it now. Yes.
So it is false, right?
Yes, now I get it. Yeah, false.
Question number 3. For pre-emphasis, we know we need a high pass filter. But you have to comment which of the following is true. What will be the characteristics of this high pass filter? So this should be the high pass filter should be with a roll up characteristics, with a particular roll up characteristics. Or so why we do pre-emphasis? Just to boost high frequency audio signals or high frequency signals, you can think. So that should be with a particular roll of characteristics. So basically it attenuates the lower frequency components. Not clearly removes. Okay. Go to the fourth question. An impulse noise in FM system occurs due to a large phase variation due to high noise amplitude sudden amplitude fluctuations in the modulated signal none of the above.
Is it due to sudden amplitude fluctuations in the modulated signal?
You're saying option B, right?
Yeah, option B.
Okay. Anybody else? So the point was there is a impulsive noise sort of thing in the FM system. So if there is a large phase variation due to high noise amplitude here, this high noise amplitude will give an impulsive sort of noise there. So this is called as the click noise. But if there is a sudden amplitude fluctuation in the modulated signal, this does not necessarily says that there will be impulsive sort of noise. There will be a fluctuation or nonlinearity in the modulated signal itself, but it says nothing about the noise here. So if there is a high noise amplitude, then there will be large phase variation because this is a FM signal. So that will generate a noise named the click noise. So this impulsive noise is certainly related to the high noise amplitude.
So then it's option A then, no? What is the
Yes, it is
answer?
option A.
Okay.
Question number 5 is very straightforward. I'm giving you 4 options and you have to comment which one of them is true.
So option C, no? Pre-emphasis is high pass
Yes, yes,
filter.
yes. Option C is the correct answer.
Yeah.
Now in this question I am giving the transfer function of the free emphasis filter. And this is h of pre-emphasis filter f is equal to alpha plus f square. Then what is the transfer function for the de-emphasis filter?
The transfer function of the de-emphasis filter should be the reciprocal of that of the pre-emphasis filter. Is it
So
right?
that will be 1 by alpha plus f square, so that hp of f into hd of f is equal to 1. So basically this is the reciprocal. So this is the answer. Again, next question is a true false type of question. So I'm writing the statement. It is figure of merit of narrowband FM is lower than that of wideband FM. True. I think everybody knows what is narrowband FM and wideband FM. So, what is the right option?
I feel it is false because figure of merit of both narrowband and wideband should be the same.
Okay. So, there are few things like spectral efficiency, and noise sensitivity. So, if we are using a wideband FM, this uses what this wideband means. FC is FC is the carrier frequency, and FC plus FM the highest deviation. So we can say what is the total dynamically change of this particular bandwidth due to the modulation. Probably we say there is a change. So if FC is like this change is very high compared to this. This is for wideband. Similarly, for narrowband sort of thing, this change is not that much high. Within this range, I should not draw like this because this says the amplitude frequency response. So probably this is the region, this is the band over which the FM is getting transmitted. But for narrowband FM, probably this is the band, this small band is over which the FM modulation is done. So when we are using, let me write it narrowband. So this is narrowband sort of thing, this is wideband sort of thing. So first of all, the spectral efficiency we can think of. So if we are using a huge frequency, so the frequency deviation first of all is minimal for this narrowband FM, because the frequency band over which we are using this narrowband FM is less compared to this wideband FM. The second point is noise sensitivity. So as we are using this narrowband FM, suppose noise is affecting particularly, and interference is also happening in this particular region for this type of thing. But for here, the deviation is very much high. So if the same noise is affecting at a higher rate in this region, it will have a greater performance. And also you can the same in the similar manner, because the noise sensitivity sort of thing, like within the carrier frequency, suppose the noise is very much high. So actually in wideband FM, what is happening, the signal is spread over this whole bandwidth, the modulated signal. But for a narrowband FM, the signal is spread over a small region. So these are the facts that a wideband FM performs better than the narrowband FM. But only one concern is here: if the whole channel has a nonlinearity, at that case, this narrowband FM may enjoy a little bit advantage, but there is no such constraint has been stated like channel nonlinearity sort of thing. So in this case, this wideband FM has a better figure of merit compared to the narrowband FM, because we can spread the signal much, and spectral efficiency is also better. Like we are using a very large bandwidth, so spectral efficiency is better for wideband FM also. Like you can use a huge bandwidth rather than a very small bandwidth. So that is going to help you anyway. So all these concepts comes here. So figure of merit of narrowband FM is lower than of wideband FM, and this statement is particularly true.
Yeah, okay, sir.
Okay. Question number 8. In a FM modulation, an increase in bandwidth results in higher figure of merit. So first option is true, second is false. So from the earlier discussion, we can easily say that if we increase the bandwidth, so if we increase the total bandwidth, that means that narrowband FM is going to be converted in a wideband FM slowly if I increase the bandwidth in a huge amount. So basically if we use a large bandwidth, that will give me a higher figure of merit. So this is also true. Now let us go to the ninth question. It is if an AWGN of one-sided power spectral density that is A naught is passed through a filter whose transfer function is given by h of f is equal to 1 by 1 plus f square. Then what is the power of the output of the filter? Okay, so let me solve the question. So what information is given that one-sided power spectral density is N naught, and this AW region is passed through a filter whose transfer function is also given by this 1 by f square. So h of f is given 1 by 1 plus f square. So, and also one-sided PSD that is given, that is N naught. So in the end, what you have to calculate, what is the power? So PSD N naught from 0 to infinite into df, that is the power, but there is a transfer function h of f, so there will be mod of h of f square also term, because this is a transfer function that comes. So this is sort of magnitude of the channel response, and when we are going to calculate the power, it should come like amplitude square. So that is 0 to infinite 1 by 1 plus f square whole square into N naught over df. And if you calculate this integration with steps, the answer that will come is pi N naught by 4. This sort of tan square formula, right? Tan square 1 plus 1 by 1 plus x square whole square. That is the key how to solve this. So the answer is this, pi N naught by 4. You have to, because it is one-sided, we are integrating from 0 to infinite N naught by 1 plus f square whole square. I think it's clear for everyone. Pi N naught by 4, that is the answer. Okay, let us go for the last question of today. For a single tone sort of signal, so for a tone signal, m of t find out the least value of FM modulation index beta such that the figure of merit of the FM signal exceeds that of DSPSC modulation. So figure of merit of a tone signal is equal to 1, whereas figure of merit of FM signal with modulation index beta is equal to 3 by 2 beta square. So 3 by 2 beta square should be greater than 1 because the question said such that figure of merit of the FM exceeds that of DSPSC modulation. So from this we can write beta square should be greater than 2 by 3 and beta should be greater than square root of 2 by 3. So this is the condition. So the question asked was what is the least value. So least value will be square root of 2 by 3. So once more, there is going to be another discussion session. So if you have any question, it is strongly advised that you should send me all those questions before I start the discussion session, because I will just prepare what is the question from your side. I have to just think once before I come to the discussion session. So just mail me the questions you have, that will be sufficient. So once again I am writing my mail ID.
So I have a question here. By which date we have to send the mail, and when will be the discussion session?
So you will be informed within 2 weeks, sort of thing. Probably this is being managed from the administration section of the NPTL, so I cannot comment on that. So
Okay.
anytime you can send me the questions, I will just if you send me the questions, I will just discuss all those questions on that day. That will be sufficient.
Oh, okay. Thank you.
Okay. So this was all for today. I think nobody has any more doubt. Then we can meet on the next Sunday.
Thank you, sir.